And today what we're going to be talking about again is stoichiometry, but more specifically we're going to be focusing on stoichiometry of gases. Now, this is something that I showed you last week that we've had before. Typically we only focused on this top half of this chart. That's what we did last term. Just thinking about, well, really it was just this side, just half of the box. It wasn't even really the whole box. It was convert to, from grams to moles or molecules to moles. And actually we did this part too, so I take that back. These three things are really what we did last term. And what's written in red is just those are the tools that we use to be able to convert from one unit to the other. Now, trying to clear the ink here. There we go. So here's an example. I know we just did an example in the homework, but I would encourage you to try to do this on your own piece of paper. Without me going through it. I'll give you a little bit of a head start, and to make it a little bit easier, I will give you the molar masses that you need so that you can actually solve this maybe before I get to the end. So how many grams of silver nitrate are needed to react with 10.7 grams of calcium chloride? So when I read that problem, the question is, what tools do I need to be able to do this, right? When I go back to this, what of these things in red do I need to be able to solve this problem? So the first thing that I notice is that it's grams. The fact that I read grams, or if I read mass, that's what's going to let me know of whether or not I need the molar masses of these compounds. So the fact that I'm starting with grams, I know I'm going to need the molar mass of calcium chloride, and because I want grams of silver nitrate, I know I'm going to need the mass of silver nitrate. The molar mass silver nitrate. Now the other thing I notice is that it's calcium chloride and it's silver nitrate. It's two different compounds. I'm starting at one compound and I'm going to the other. So this is what lets me know that I need the molar mass, right? This part here in the middle. Or I'm sorry, not the molar mass, the mole ratio from the balanced equation. So I know I'm going to need that as well. So when you look at, in terms of what's given, and my choice of font color is not really what it should be. This says this is a 2, and I'm realizing now that I forgot to write the equation for this to show you where I actually get the 2 from. Oh, that's a terrible color as well. Do this. There you go. So that's what's written over there in red, if you can't see it. So if I had realized that I didn't write the chemical equation, you would see that that's where I got my 2-to-1 ratio from. But anyway, so those are all the tools that I'm using. So I'm going to write down what I'm given in the problem, which is 10.7 grams. Draw my X, draw my line, and then look, I got grams of CaCl2. So grams of CaCl2 is what's going to go on bottom. Why? So that the grams cancel. That leaves me with moles of CaCl2 on top. Well, now is when I use the mole ratio. So I put moles of CaCl2 on bottom, which is what's going to put the 2 moles of the silver nitrate on top. And I kind of just continue on, canceling my units, setting it up so that top and bottom cancel out until I'm left with the unit that I want. When I look at my problem, what am I solving for? I'm solving for grams of silver nitrate. And so then it's just a matter of inputting it into my calculator. So if a number is on bottom, I divide. And if it's on top, I multiply. So it would be 10.7 divided by 110.98 times 2 times 169.87. And we get an answer of 33.3 grams. So let's talk about stoichiometry with gases. Now this is something, can I go back? Yes. I will remind you there is also a hard copy of these notes on Schoology. So if there's ever, if you miss something and you need to write it down, you can always have those. And I actually would encourage you, maybe it's a good idea to have the hard copy of these notes open as we go through this so that you can reference them as we're going through. So to get the 33.3, I take my 10.7, I divide by 110.98 because it's on bottom. I multiply by 2 because it's on top, and I multiply by 169.87. So I'm just multiplying my fractions that I've created here. So when it comes to gases, last term when we talked about gases, we were doing Boyle's law and Charles' law and the ideal gas law. We had these types of things, right? So it was a shorthand way for us to describe conditions without having to list all of the conditions. So we have standard temperature and pressure, which is STP, which is 1 atmosphere and 273 Kelvin. But we also have standard room conditions because typically we do experiments inside and it's not 0 degrees Celsius. So we raise our temperature to 25 degrees Celsius. Now what we learned then is something very interesting, that at a given pressure and temperature, like STP, 1 mole of any gas occupies a volume of 22.4 liters. As the temperature goes up, our volume goes up. But the same relationship is still true, that at SRC, 1 mole of any gas occupies a volume of 24.5 liters. And so what we have here is we have a way to get from a volume of a gas, which we can measure and observe in the lab, and that gives us a way to calculate moles of that substance. Because right now the only tool we have is a balance, right? I can put something on a balance, I can weigh it, I can find its mass, I can convert to moles. But how do you put helium on a balance? How do you find the mass of helium or the mass of oxygen in a balloon? That is really difficult for what we have. And so instead, for a gas, is we use this. We use this relationship, that as long as we know what the pressure is and the temperature is, if it meets these standard conditions, then I can just measure the volume of the balloon, and that's going to tell me how many moles of that gas I have. Okay? So what we have right here is a way to get from something we can measure in the lab to moles, right? So this is just, it's another tool that we have at our disposal to be able to convert to moles. And then again, if I can convert to moles, then I can convert to anything else because I have the mole ratio and I can do kind of anything I want. So let's look at an example of this. So here is, I want to produce 15.4 liters of hydrogen at STP. So how many grams of zinc chloride is produced? So what I'm doing here, if I can go back, is this is where I'm starting. And I want grams of something else. So this is where I'm ending. So that whole kind of first step that I do is like, I think about what tools do I need to be able to solve this? Well, I know I'm going to need this. I know I'm going to need this. And I know I'm going to need this. And so it outlines kind of what I need and what I need to do in order to get from one side of this chart to the other. So it tells me that it's at STP. So that tells me that 1 mole of hydrogen occupies a volume of 22.4 liters, so I know I need that. Here's the mole ratio, and again, I apologize for my font choice. What I'm looking at right here are just the coefficients of the two things that are involved in this problem are just 1, so it's a 1-to-1 ratio. And then I need the molar mass of zinc chloride, which is 136.29, right? So I don't need the molar mass of hydrogen. I don't need the molar mass of anything else that's in there. I only need the molar mass of that B compound, that compound that I'm actually converting to. So these are the things that I'm given. So to solve this, step number 1 is take what you're given, write it down. So there's my 15.4 liters of hydrogen. And then I'm going to put my 22.4 liters on bottom because I want it to cancel. That puts 1 mole of hydrogen on top. The next thing I do is use my mole ratio. So I'm just following that flow chart, which is just a 1-to-1 ratio. And then the last thing is the molar mass, which is 136.29. So again, I have set this up so that my units cancel. So liters of hydrogen cancel out, moles of hydrogen cancel out, and moles of zinc chloride cancel out. So the only unit I'm left with is the unit that I'm solving for. So then to plug this into your calculator, and I would encourage you to put this into your calculator now so that you can practice this, it would be 15.4. And then because the 22.4 is on bottom, I'm going to divide. So 15.4 divided by 22.4 times 136.29. Right? I'm ignoring all of the ones because when you multiply by 1 or divide by 1, nothing happens. And I get an answer of 93.7 grams. Yep. So if you punch this into your calculator and you did not get 93.7 grams, then you did something wrong. So here we have a similar problem But this time it's at SRC. And so ultimately it's the same kind of thing. But this time it's different substances, right? So I'm starting here with zinc and going to hydrogen. So my mole ratio is still the same actually, because it's 1 mole of zinc for 1 mole of hydrogen. I'm starting with grams of zinc, so I need the molar mass of zinc, which is 65.39. But then at SRC, my value changes. Instead of, that's a typo, instead of 22.4, it's 24.5. Because I'm at SRC. So then I take my 1.5 grams of zinc. This is grams of zinc, so my molar mass goes on bottom. I now have moles of zinc, so now I'm using my mole ratio, which is 1 to 1. That gives me moles of hydrogen, so now I'm going to multiply by 24.5. And again, I'm doing this so that my units completely cancel out. So for math, this is 1.5 divided by 65.39 times 24.5. And you get an answer of 0.51 liters.